All right, good morning. Here we are at 5.2, and the things we have today are scale, Petri dishes, and then all of these cups of water, a little measuring cup, and some food coloring. So we have to work kind of quick, so we'll explain more in a minute.
But we're testing the salinity, how salinity affects ocean currents. Okay, salinity meaning salt. So we're going to take, this is frozen seawater.
So is this.
But we have some liquid in it, so we need to pour out the liquid and save the ice.
So we're separating the liquid from the ice.
Oh, and it's freezing my fingers.
It really is pretty cold.
It's so cold. Whew. Holy smokes.
Okay, I feel like that's good enough.
And I
So
think
B
mine's about done.
was poured into G.
I have hypothermia. One or the other.
Well, if your finger falls off, it'll be like Adam Sandler, his friend that has the black foot. Remember that show?
Okay.
So
I think
A
that one's good.
went into F. Okay, now we can explain a little more. But we just pulled those out of the freezer, and we needed you
Very
to know.
cold.
So A and B are frozen seawater with the
Okay.
same amount of salinity.
Yes.
And salinity means the amount of salt in it.
So let's compare because these were frozen, as was E. So I'm going to pull this up. This is frozen freshwater. And these were frozen seawater.
And they started out with the same amount of liquid in them yesterday. So E is up here, and now B is down here because we poured out the liquid that did not freeze.
So if you just kind of make some observations, right, you probably noticed right away that A and B, the frozen seawater, was not completely frozen. It had liquid, and that's what we poured out. Where
E, on the other hand,
E, very, very frozen
yeah.
all the way through. So
Now-
just some observations.
Yeah, tell me about C and D,
C and D are, well,
just so we know what we're starting with.
those are liquid seawater. So these were the exact same. B and C had the exact same thing in it.
Yeah,
Same amount
A,
of salt.
B, C, and D all had the same amount.
Right. The only
Yep.
difference is these two we froze and these two we left as liquid.
Perfect.
The only difference.
And then the frozen freshwater, you know, and then these two we just poured out from A and B, as you'll see on the label. Okay, what's next?
So we need to kind of talk a little bit about seawater and how seawater freezes. So maybe a little bit about why these didn't freeze completely. And so it can get kind of complex. But as you know, oh, I need a marker. Hold on.
Pause.
No.
We're back.
Okay, so if you know very much about molecules, right? We have, if this is a water molecule, it's made of 2 hydrogens and 1 oxygen, okay? And it makes this kind of V-shaped molecule is basically what it does. And that's what water is. And so what happens is these ends have a polarity. So like they might be negatively charged or positively charged, etc. But when you add salt into the mix, it changes these shapes a little bit. And so then it has a hard time with the pieces fitting together like a puzzle. So
Right, because when water freezes, we know it expands. And it expands because all of these things have to line up just so when it freezes. But when
Yes.
salt's there and it can't get in its just perfect shape, weird things happen.
Right, and so it doesn't have the ability. So basically, the gist of it is, it doesn't fit together, nice and tight like a puzzle piece would. Salt also lowers the freezing temperature of water.
Right.
So where water would normally freeze at, anyone know?
I think it's at 0
0 degrees.
Celsius. Whoop, whoop.
The salt makes this water freeze at a lower temperature.
So minus 0, like
Yes.
below 0, or below 32 degrees if you're in the Fahrenheit world.
And I don't know that exact number. Sorry. Anyway, so that's kind of the gist. The next thing you're going to do is answer question 4. And so hopefully that a little bit of background information will help you answer question 4.
All right, good luck, and we'll see you tomorrow. Well, it'll still be today for us, but it might be today for you. But we'll see you in the next video.